Hi, my name is Sarah Dressel. I'm the developer of Junkyard Universe, and today I want to talk about how saving and loading works in the game with Godot. Now, I know of three ways of saving data for a single-player game. Now, the first one, the config file, obviously will also work for multiplayer, but as soon as you start saving player data, you might want to save that in a different kind of way in a database. So because you might want to protect it from kind of manipulations. If someone manipulates the game in a single player game, that just ruin their own experience. So that's their problem, I'll say. Now, the first way to save things, as we see here, is the config file, which is basically for settings. And there's a pretty good description about how to do that in the Godot docs. So what I'm saving in the game with the config file is, well, the settings, yeah, the language, audio, and so forth. Yeah, this is the documentation in Godot. I'll link that in the description. I think that's pretty good, so I'm not going any further into this topic. Now, the second thing is saving data in JSON files, and in one JSON file, and this works pretty well for saves, for game saves, as long as you've got a single player. And there's also a description about this in the Godot docs. And I use this for, saving the game. So what actually happens inside the game. And I started with this description, but then when it comes to the loading part, I decided to do it a bit differently, which I'll explain later. But for now, there's also something in the Godot doc that I'll also link, and I'll get back to this in a minute. And the third way to save something is as a resource. The advantage of a resource is that it supports more Godot-specific data types like vector2 and so forth. So if you have a lot of these, you might want to look into using a resource for saving. I didn't. I think I've got like one vector2, and you can also split up vector2s in X and Y. So not necessarily has to be used here. And what you also have to know about saving things as a resource is that there's a potential security issue. So if you're interested in doing the resource thing, please check out the tutorial by the Godotneers, because they also got that security issue covered, and it's really a really good tutorial. So that's their tutorial. I'll also link that in the description. So what I want to talk more about now is saving things into JSON files, because that's what I did for Junkyard Universe. So again, I started out with the documentation. And what a documentation tells you to do is, in very simplified way, is this. You put all the nodes you want to save in one group. Okay? And when you got this, you go into each of those nodes and write a save function. And everything the save function does is that it puts everything you want to save in this node into a dictionary and then returns it to whoever calls the save function. For example, if you go into the player because you want to save the player, one of the things you would put in a dictionary would typically be something like player health. And then next you got the save game function, which is called from like whatever manages your save game process. And the save game function now calls all those other save functions inside those nodes and collects all those dictionaries. And then it turns those dictionaries into JSON and writes all of that into a JSON file. That's how saving works with JSON. And then, of course, we also want to load the data again. So saving, compared to loading, saving is actually pretty simple. Where it gets complicated is when you load things again, because you don't only want to load something, you also want to make sure the game works after it's loaded. So you load back the JSON file, and you turn the JSON back into something that Godot can work with. And then, according to the tutorial, you're supposed to delete the existing nodes and then replace them with nodes generated based on the saved data. Now, this is fine if you have something like items in an inventory. I think I did it the same way for those items. Or if you got like enemies or obstacles flying around in your game, that would be where you use that for. But if you got something like this, and I don't mean the speech bubble, I mean what's causing the speech bubble, which is the conversation engine, you might run into problems. Why is that? Well, if you delete the existing nodes and replace those nodes with once generated anew, that's again, it's fine for stuff like moving objects, like enemies and items in an inventory. But if you got interconnected systems, like in my case, the conversation engine, you might break those connections. And the other problem is that if you have savable nodes inside savable nodes, for example, I want to save the main because there's stuff in main that I want to keep, and of course all the other nodes are inside of main. And if I then like remove main and then I have to put everything back into main, this might cause problems. So I decided to do it differently. What I do instead for loading games in Junkyard Universe is I also load a JSON file and then turn it back into something Godot can read. But then I sort that back into the nodes so that each node has its previous information that it saved. Then I completely reset the game to a new game state so that I don't have any old from the player might have been playing the game before he hits load. So I gotta clean up so that I got a kind of a clean sheet, so to say. And then I run a node specific load function for each node. So I get into each node and tell the node how to restore its saved data. And then I also, because I reset the game to 0 pretty much, I gotta start the game again. And how I start it again depends on the game state, which is a very important data to save in my game. And then, last but not least, you gotta sprinkle it all with a truckload of error handling, because you cannot guarantee that whatever save game the user tries to load is one you actually created. That's why saving data is so much easier, because in the moment you save it, you know, this is data for my game. I don't have to check if it's plausible. But if you load it, there might have been a problem while saving, so even your own game can create buggy save files. Or, for example, if the computer crashed while trying to save the game, then the save file will probably not be correct. And the other thing is that some users will try to either manipulate the save game themselves, or maybe they share save games. And so you cannot guarantee that the save game you're trying to load is actually functional, like it has all the data it's supposed to have and makes sense. So that's why you need a lot of error handling. Now, let's see how loading, and now I want to show you those blue parts. Like I'll show you how I load a game in Junkyard Universe. And for that, I will go to the Godot engine. And this is just an image, so I'll get the real deal. And here is the save and load game function. It's pretty straightforward. It has a save game button, a load game button, and here's some here's a label for some feedback, like saved successfully or there was an error. And if we go to the load game button, we can see over here what the signal connects to. And it actually connects to this function on load game button pressed. The first thing it does, the save game menu hides itself, because usually if I load the game, I want to play the game and no longer want to be in this menu. And then I goes to the save manager and tells him, to load the game. And if there's an error, this error is placed into load game error. Then we check, is there an error? Because if there's none, then it will be none. But if there's an error, then we reset the whole game again. We go back to we go to a save game menu, and we display this error. Because if there's an error while loading, you might have a really weird kind of state that the game is in, so I'll make sure to reset this before I go back. Now let's go to the actual load game function. So let's go to the save manager here. And here's the load game function. And here I mentioned this about the truckload of error handling. So I start off with, first of all, I say none. So if this runs through and it's still none, then it's perfect. Then there was no loading error. And also prepare this other variable for a JSON error. And ideally, there's also no JSON parse error. Then we check if this file even exists that we want to load. Because if there's no file, we cannot load anything. And well, if there's no file, we just return the loading error and stop here. But if we have a file, then we try to read that. And then we go through this file line by line, get the lines. We create this helper class that will help us to interact with the JSON. Because this helper class can now pass the JSON string we got from the save file. And then we again check, is this result okay? And if it isn't, we get the parse error, which goes into JSON error. And for now, but here we continue. You'll see why later. And then from this JSON object, we get the data and the node data. And now this thing we pretty much can use like the dictionary we created before. So I can now say, from this node data, I want to match the file name. Now, I've got here some commentary which says still missing half a truckload of error handling. Because actually, before I try to call something from this dictionary, like the file name, I should check if this key even exists. I didn't do this yet. I still have to do this, just as a reminder that maybe you want to do that too. So now I go through the file name. This is something I've put into the save function. And for example, if it's main, it puts this into main node data. If it's a player, it puts it into player node data. So I now have all my data sorted back. Like I know which node and which data belong together. And just in case there's something I didn't expect, we have a little error handling here. In this case, it just prints, whoops, what did we save here? So now, more error handling. we check if this data that we just hopefully wrote in there even exists. If it doesn't, then we need a loading error which says corrupted save file, main node data is missing or corrupted. And often this is caused by a JSON error, so we just stick the JSON error onto this. Because every time there's a JSON error, there will also be an error from one of those nodes, because then it can't load those nodes. Sometimes when if you completely cut out the node, there will not be a JSON error. But usually in all other cases, in most other cases, there will also be a JSON error. So, and this is for all the nodes, blah, blah, blah. So now, if we didn't have an error yet, we actually continue here. And first thing we do is we go to the main node and load that one. Because what the main node does a little more than just loading its data. That's why it's the main. Main gets the main job to do. And here again, I should check if those keys exist first, but I didn't do it yet, just as a reminder. Now, what it does, it prints me this into my debugger. So I, just in case, while you write a load and save function, you'll have to do a lot of debugging, and you really want to know which part this arrow came from. Now, the first thing it does, it looks pretty harmless. It resets the game. That's pretty important. What reset game exactly does depends on your game. We can have a quick look at it. Here it is. First of all, it pauses the game. Then it cleans up all items that might be flying around, but this refers to items in my case that are flying around, not in the inventory. Then it resets the level. I'm not going to, it's even more complicated. We stop the tutorial timer in case it's running, and reset the player node. So basically, we reset all the other systems to make sure it's like a clean state, as if, and we say, okay, game mode is mode new game. So we reset everything so that it looks as if it was a new game. So once we reset our game, we load some more data, for example, the difficulty level. And in the difficulty level, that's another thing. That's like, you cannot just change the difficulty level, because changing the difficulty level means you change the difficulty level for the main, but you also got to inform the player and the item spawner that kind of adjust themselves to fit the difficulty level. And this is actually, that's what I mean with interconnected systems. They kind of got to inform each other so that everybody of those systems knows what's going on. And that's why I decided to have a distinct load and save function. If you just want to do like this, just have only data that you want to update, you don't really need to do it like this. But in my case, like, for example, also load level is also something that informs a lot of other things. And if you do your own load and save function, you just have the ability to the chance to change those things. And this one is also an interesting example, because this is a Boolean. Is player outside in hunger, yes or no? But I don't want to just initiate those Boolean. But if it's true, then I kind of, if the player is outside of hunger, which is a bit of counterintuitive, but then you hide the hunger, and otherwise you gotta do it differently. So, and that's basically it for the load save. You kind of call several functions that first of all, reset game, that's the most important one. Then I call, depending on what it is I want to load, I either call a function to do that, or just put it back in there. And then we handle all the data we get from the dictionary. And this is all the data. We know exactly which data should be there, because this is the data we saved before. You can here see the dictionary we sent when it was saved. This is all the data we saved. And so we know which data we gotta reuse, load again. So, and when it's done, it goes back to, we get back to the save manager, and the save manager continues to go to the next node, in this case, the player node. I also show you the player node because I think most people will have a player node in their game. And here, for example, I gotta install an upgrade if I have it. And then some things are pretty straightforward, like I got dissolve energy. That's like you can consider it the ammo of the dissolve particle projector. And there's repair energy, and then there's ship health, because I'm in a spaceship, and maybe I want to activate shields. And you see the player, for example, is more straightforward than the main, because the main is more complicated, because it gotta handle everything else. But almost every information I got in the player also emits a signal, and this signal goes to the heads up display, so that not only the player, the code knows that you just have you got so and so much dissolve energy, but it's also displayed for the player, so you can see it in the heads-up display. That's why almost all the information the player gets has a signal he has to send. And we go like for all the nodes like this. I've got the main node, the player node, the space station. The point of the space station being is that the space station arrives once you cleaned up a level. And I gotta know where the space station is, because if the space station was in the process of arriving while you save, and I forgot about saving the space station, you're kind of stuck in the end of this level forever, because it will no longer be triggered that the space station arrives, but the space station is also not arriving because, well, we forgot to save it, so the space station needs to be saved. The inventory manager, that's pretty clear. We want to know what kind of things we got in our inventory. The conversation engine, so we know what we're currently talking about if we're in a conversation. The video player is if we're currently playing a video. And the item spawner, so that we know what it was doing. Now, here again, I go back to the main node. Now we loaded all the data. And now we also got a start loaded game. And this may also cause an error, which is why I store this arrow into loading error and return it if it's here. So let's see how we restart the game. If we go into main, it's right here, it's start loaded game. First of all, we do another bit of error handling. If there's a loaded game error, first of all, we start off with none, and hopefully we'll stick with none, but maybe there will be one. And first of all, I tell the game that it is started, which is important for the menu, because the menu will not allow you to resume a game if the game is not started. And then it depends on what the current game mode is. So if the mode is game action started, then I will start the game action, which kind of makes sense. If I'm in a conversation, then instead I will make sure we are no longer spawning things, and we start the loaded game from the conversation instead. If I'm in a video, I'll start a video. And if I'm in tutorial, it's a bit of a special case, because then I want the hangar to be there. That's where the tutorial happens, and then we also go to the conversation. So, and if none of those cases is true, we've got another wonderful error, which is the about the wrong game mode, because if this game mode is not loadable, we'll get an error. There's some game modes that are in-game that are not loadable. That's if I have a new game, because it doesn't make sense to load a new game. There's nothing different from start new game. If the player won or if the player died, you cannot. You shouldn't be able to save this game, so you can also not load it. But you never know what goes wrong, so you better safeguard this. Or if someone messed around with the save file, then of course this could be wrong. So we'd return the load game error, and then we'd be back at the save manager. And the save manager also returns this loading error further back to save game menu. And if we have a loading error, it can then pass this on to this function to display it. Or if we have no loading error, we hopefully have a running game. Well, short recap what the function did. We saved the game by putting all the nodes we want to save in a group. And each of them has a save function, which returns a dictionary with data for this node. And we also have a save game function, which goes through all those nodes, collects the dictionaries from the save function, turns them into JSON, and writes this into a JSON file. And then when we load the data again, we load the JSON file, turn it back into something Godot can actually read. We sort it back into the nodes, then reset the game. Don't forget about it. And we run a node-specific load function for each node. And then we start the game again, depending on the game state. You might have different game states depending on what kind of systems you have. Maybe you don't need a game state at all if there's just one kind of game state. depends on your game. And we need a truckload of error handling. Right now I have about half a truckload, so I need another half a truckload of error handling. Yeah, that's pretty much it. Thank you for listening. I hope this is somehow helpful to you. If you liked this video and if you became kind of curious about what Junkyard Universe actually is, you can look at it on Steam. I'll also link this in the description. And other than that, thank you again for listening. If you have questions, feel free to ask them in the comments, or if you have something you like to add or other ideas how you save and load a game, please also add it in the comments. And yeah, I'd like to see you again. Bye bye.